Hello, I'm Rod Ross with MedLogix, and we're here today to provide you with training on the ML7. This is a video to provide supplemental training to staff personnel in addition to the initial training that would have been provided at the time of installation. The training video should not be the only training for anyone using or processing the ML7. The ML7 Operator's Manual should be referenced and reviewed. The ML7 is the first software-controlled microqueratome to provide advanced performance and safety features such as load compensation during the flap creation to provide a planar flap that will optimize post-op vision and rapid recovery. In order to maximize the patient benefits offered by the ML7, it must be cared for properly. This training video will review the proper assembly, use, and cleaning requirements for the ML7. First, let's start with the console. On the rear of the console is two primary connectors. First is the power connector, and that is simply attached by using this electrical cord, and it cannot be put in incorrectly. It will actually go only one way. Push it in all the way to where it's secure, and then the next connector is the foot pedal connector, and this is a screwed on connector that will also only go one way. It has notches that will determine its proper alignment, and it is screwed down tightly. And so there's your two connectors, and then there is a power switch here in the rear, and this should be left on all times so that the internal battery will be charging when it's plugged in, and it must be turned on to actually operate the device. And then on the front of the console, coming from this side first, is the power switch. When turned on, the software will actually go through its safety check, and it also draws down the vacuum reservoir. Many doctors will actually use this device at somewhere between 550 and 600 on a routine basis. The vacuum is the only thing on the console that is adjusted, and the lower the vacuum, the thinner the LASIK flap. The higher the vacuum, the thicker the flap. And then you get over to this side, you have the vacuum tubing connector. This is a simple Kohler connector, and this must be pushed down to accept it, and you will hear a firm click, and it is fully attached. So this is your vacuum line, and then the other connector is the ML7 handpiece, and this is a LEMO connector, so it's a red dot to red dot, and it also will snap into place, and that is fully connected. So this device has software-controlled performance functions and features and software-controlled safety features. Now, on the foot pedal, this has a forward foot pedal, a reverse foot pedal, and this is the vacuum button in the center. Please notice that the vacuum button activation and deactivation is at a higher level, which helps protect the user from inadvertently touching it at any point. The surgeon must elevate their foot in the center to activate and deactivate this. So the forward and reverse buttons, foot switches, can be operated to position the head on the vacuum ring prior to use, as long as the vacuum is not activated. Once the vacuum is activated, that is for the actual cutting of the flap, and in that case, the surgeon actually keeps the forward foot pedal down after activating vacuum, and the device will go forward, cut the flap, and automatically return. However, the surgeon must keep this foot pedal depressed. The handpiece is small and lightweight. It has two 6mm diameter motors with planetary gearboxes inside. One motor drives the oscillation of the blade. The other motor drives the head forward across the vacuum ring. Each of these motors controlled by software in the console. The software reads the motor speed each 50 milliseconds so that any resistance felt, the software will maintain the proper speed in the handpiece. So when you activate the forward pedal, it activates the drive pin. The drive pin controls the blade oscillation. You can see it has very good strength, and that is in large part due to the software control. This handpiece should never be put in fluid or allow fluid to enter it. It's best to keep it upside down like this, even when cleaning the drive pin. Then inside the component tray, there are, depending on the surgeon preference, either a 100 or a 130 micron head. These heads are one piece, and they're very reliable, very accurate. The critical dimension is plus or minus 5 microns. It's made from a 420 hardened stainless steel with 5 microns of chromium coating on it for lubricity and strength. The vacuum ring is also made from 420 hardened stainless steel with 5 microns of coating, of chromium coating, and it features a patented 4 vacuum slit design to help prevent pseudosuction. You notice it does not have round vacuum ports, which can be easily occluded by conjunctiva and give false suction. That's why they call it pseudosuction. This vacuum ring has elevated rails to help keep the lid out of the procedure, and it has a helical drive, which provides very smooth movement. The vacuum ring handle is made from high-grade stainless steel. Please notice it has a permanent red O-ring on it. This O-ring should remain there at all times. If it's missing, it should not be used. There should be a replacement applied, because that helps secure vacuum. And then the cornea marker is also a key to preventing free caps. This will actually help the surgeon center the flap. The ML7 features a blade shuttle system, which is very simply used to move the blade and insert it into the head. And there is the large opening here on the side of the head mates up to a prong in this area of the tray. So drop the head into the tray this way, and then make sure that it's secured, and then move the blade using the plunger. You move the blade right into the head, and while the plunger is in that position, attach the handpiece, remove the plunger from the area, and open the tray by moving the handpiece out and rolling it up. And then press the forward pedal on the foot switch and make sure it's oscillating properly, and you're ready for surgery. Now the head and blade are attached to the handpiece. We will now assemble the vacuum ring handle onto the vacuum ring. Please note the red O-ring on the end of the vacuum ring handle. It just screws into the side of the rail like this, securely, and then take the white connector at the distal end of the vacuum tubing and tighten thoroughly. Make it very secure. You do not want any vacuum leaks at any connector. and then hold the vacuum ring at the lower area like this, and then take the handpiece, also hold it at the lower area. There's a notch on each side of the rail, which mates up to the bearings on each side of the head. And one way to do it is simply put it on top, pull it back, and let it fall into place. And it will always fit only one way. This helical drive fits into this opening here. That's how it attaches for its automated drive. So put it up here, pull it back, let it fall into place, and then only touch the forward pedal on the foot switch enough to get it attached. And you'll know it's fully attached by just gently pulling it back, and that way it's ready for surgery. And then there are, you don't want to put it on too far. The surgeon will have their preferences. If you needed to move it back a little bit, you can use the reverse on the foot pedal. So we're ready for surgery. The technician will put it down on its side until the surgeon is ready to use it. And then we will use the eye marker, hand it to the surgeon. The surgeon will mark the cornea appropriately. Then the technician will hand the surgeon the handpiece assembly, and then the surgeon will align the hash marks on the vacuum ring to the lines on the cornea. Press the black vacuum button on the foot pedal. When the beep is heard, it's telling the surgeon that the surgeon can proceed with cutting the flap. Press the forward pedal, leave it down, and the device will back up automatically, and it will always return to its exact starting point. The surgeon will then press the black vacuum button. That will relieve vacuum. The surgeon will hand the device back to the technician, and nothing will be done to it because it's ready for use on the second eye. One of the things that we were told by surgeons that have used other devices in surgery was that if it jammed on the eye, they had difficulty in removing it from the eye. So we developed a wrench that allows the surgeon to actually remove the device easily, simply, quickly if it were to jam on the eye. So let's assume that it jammed on the eye. Use this wrench, put it on this nut, break the nut free, and then remove the nut quickly. And then it simply slides off the eye. And then it can be reassembled by putting there's a number on this, and you put the number on top, slide it into the groove like this, and then reattach the nut. Only put it snug with your fingers, and then attach the head and hand piece and bring it almost to about further than halfway, and then while it's in that position, tighten it. Be sure not to over tighten. This is a soft nut to secure it easily, and then test it on a pass and make sure it's operating properly like that, and it's working fine, and you're done. At the end of each surgery, it is very, very important to clean properly the components, and the components in question is the head, the vacuum ring, and the handle. The two critical parts is the head and the vacuum ring, because this is a very, very tight tolerance device and it must be properly cleaned for it to function well. So the way this works is to use distilled water and thoroughly clean all cavities and open areas with this small brush, both sides, the blade cavity and then the blade exit cavity, and all of these areas, and then use the larger brush to get more of the outer area. And this must be done after each procedure. And be certain to clean the rails, which interfaces with the rails on the vacuum ring, so that after each component is properly cleaned, it goes into this ultrasonic basket. So on the vacuum ring, it's important to thoroughly clean the vacuum slits and the underside where any material could have been pulled into the vacuum path inside the vacuum ring. Thoroughly clean the rails on each side and clean the helical drive like this to make sure no material is remaining on it. Clean the surface of the vacuum ring like this, and the cavity inside where the handle goes inside, and then put it in the ultrasonic cleaner, and then be sure and clean this vacuum handle well. It's always best to also put a syringe and blow any fluid out of it after you clean it. And then put these inside this plastic tray ultrasonic cleaner. It's important that it be a plastic tray, because if it's a metal tray, it can actually damage the chromium coating on the heads and the vacuum ring. Between procedures, it's best to clean it for 3 minutes in the ultrasonic cleaner. However, at the end of the day, it's best to go through the same cleaning procedure, and at the end of the day, leave it in the ultrasonic cleaner for 10 minutes. So between the cases, it's best to ultrasonically clean it for 3 minutes, and then soak them in a separate bath of distilled water and get any material off of them there. And then between the cases, you can autoclave them in a sterilizable tray or something that can endure the high temperature